All right, today's notes, 8.2 Pythagorean Theorem and Converse. We're going to use the Pythagorean Theorem to find the missing side of a right triangle. Sides A and B of a right triangle are called the legs, and side C is the hypotenuse. It's the longest side, and it's directly across from the right angle. For any right triangle, the sum of a squared plus b squared equals c squared. So if we need the missing side here, this is a, b, and c, we would just set it up. 16 plus 36. Square root both sides to get x by itself. So x is equal to 2 times 3, now I can't remember. Okay, it's a 2 and a 26 and a 2 and a 13. 2 times 13. So 2 square roots of 3. In this case right here, we have a right triangle where the sides are 5 squared, A, B, and C, plus the 18 squared will give us the C squared. Now 349 happens to be a prime number, so that would be okay, so we need to take this, that happens to be prime, so you would either leave it like this, or if you needed a decimal approximation for any reason, it would be approximately 18.7. In this next triangle, I've set up A, B, and C. Now A and B are interchangeable. It doesn't matter which ones you choose for A or B. C is the only one that always matters. And just have the calculator do this. Oops, I messed something up here. What was it? 5 square roots of 13. Okay. This is really a 25 times a 7, so that's 175. And a 325. Square root both sides to free up that x, and 150 is the same as 2, 3, 5, 5. So 5 square root 6 is the answer. Now let's look at a word problem. This one says that Calvin found a map which promised buried treasure if he followed the route exactly. He must travel 9 miles to the north and 12 miles to the east. So thinking of north, east, south, west, he went 9 miles north, 12 miles east, and we want to know how far is he now from his starting point. So just form a right triangle with that. Set up A, B, and C. Let's make that X right there. We've got an 81 and a 144. Square root both sides. I didn't mean to do it that way, so sorry. Let me just redo that because I'm getting bothered that I keep doing that. Okay, so no, this is the process. You add these up, obviously, equals x squared. So we got 225. 225 still equals x squared. And now I'm going to square root the x squared to get rid of the square root, the square, because the square root of x squared is an x. And that forces me to square root that side, and the answer is 15. So 15 miles, he's from the starting point. All right, given this is the Pythagorean Theorem Converse. Given a triangle with sides A, B, and C, then if C squared is equal to the sum of A squared plus B squared, then we know we have a right triangle. If c squared is greater than the sum of a squared plus b squared, then the triangle is obtuse. And if c squared is less than the a squared plus the b squared, then the triangle is acute. And one very important thing to keep in mind is always keep that c squared on the left side when you're trying to determine what triangle it is, so that you don't mess up these symbols. All right, c squared has to be less than the rest for it to be acute. C squared has to be greater than the rest for it to be obtuse. So for this first section here, we're going to determine, first of all, if these either even are triangles. And remember, in order to do that, you need to take the smallest sides. The 3 and the 7 are the smallest. That makes a 10. If 10 is greater than the last side, then it is a triangle. Let's set up our c squared first. We're going to set up our a and b next. We're going to see what symbol do we get. An 81 and a 58. So 81 is greater than the 58, so this is an obtuse triangle. In this case, the two smallers make 41. That is greater than 29. Let's put our c squared first. And we're going to find out what symbol compared to adding the squares of this side. And it winds up being 841 for this one. And the sum of these actually wind up being 841 as well. So these two are equal. So we've got a right triangle. Let's apply some more right here. So this is just A, B, and C. We would set it up like this and find C. This is A, B, and C. So this one, if you factor out, is a 2 and a 64, an 8 and an 8. So we have 8 on the outside because we have a pair. 2 will be left in the middle. I did it again. Okay, here we go. We've got A, B, C. So A, B, C, and solve for A. A, B, C. A, B, C. And this one we would set up just like the rest. All right, so for these word problems, it says a commuter airline flies a new route between two cities that are 400 kilometers apart. So I'm just going to make myself a diagram that shows that two cities, I'm going to call them A and B, are 400 kilometers apart. One of the two cities is 200 from a third city, so this will be my third. Now, obviously, I don't know if I'm even drawing this correctly. I'm just drawing it for my own self. The other of the two cities is 300 from the third city. Okay, so it's saying do the paths between these three cities form a right triangle. Well, obviously from my picture it does not, but that's not how we're going to determine it. We're going to take the largest side, and that's going to be our C. Our smaller sides will be A and B. And we're going to see what we get here. $90,000. Okay, how does 16,000 compare to 13,000? Okay, 130,000, so it's greater than, so no, it is not a rectangle. I mean, not a right triangle, because they aren't equal. In fact, it is obtuse because it's greater than. Here, a school wants to build a rectangular playground where the diagonal is 75 degrees. I mean 75 yards. All right, so we have a right triangle right there. How wide does it have to be if the length is 30? So this is 30. Let's figure it out. X squared plus 30 squared equals 75 squared. 30 squared is 900. 75 squared is 5625. Subtract out that 900 from both sides. X squared equals 5. Where did it go? 4, sorry. 4, 7, 2, 5. So square root both sides. This gives us a decimal approximation of 68.7. A 250-foot length of a fence is placed around a 3-sided animal pen. 2 of the sides of the pen, so let's make our triangle. 2 of the sides is 100. The third side has to be 50 because it says 250 total. So it's saying, what type of triangle does this make? Well, if this is A and B, because those are our smaller sides, and this will have to be our C, let's put our C first, and then our A and B next. And we're going to get, let's see, 10,000 plus 2500, 10,000, 12500. I feel like I did that wrong. Is less than, so we're getting an acute triangle. Next one, for all of these, determine if they form a triangle. If so, is it acute, obtuse, or right? Okay, smallest sides, 24 plus 7. 24 plus 7, I already know is greater than 25. It's a 31. So yes, this is a triangle. Let's test this one out. 70 is greater than 45. 1.6 plus 28.8 is 50.4. So yes, this is a triangle. 10 over 15, 25 is greater than 18. These two, 46.5, no. That is less than the largest side, so that is not a triangle. This would be 6.5 exactly, so 6.5 is equal to 6.5, so that is not a triangle. So from all the others, let's go ahead and test out what kind of triangle it is. I'm just going to write them all out. C's on the left. This one, 36 squared, 216 squared, 288 squared. This one, 18 squared. Okay, in this first one right here, 25 squared is 625. What do we get on the right side? We happen to get 625 as well. So we've got a right triangle. In this case, what do we have here? For the 45, we have 2025. Oops. For the right side, we have 2500, acute. For this side, this triangle, we've got 1, 2, 9, 6, and 1, 2, 9, 6. They equal each other. So right triangle. And the last one, we have 324 and 100 plus 15 squared, 225. So we have 325 compared to the other side of, oops, I wrote that wrong, didn't I? Of 325, this side was actually a 324. So this side is, the c squared is less than the sum of the a squared plus the b squared. So this is another acute triangle.